Welcome to this lecture on Microcontroller 8051 introduction. We'll be discussing about the architecture, types, features, block and pin diagrams of the Microcontroller 8051. So let's start. The microcontroller in short can be said is a circuitry of microprocessor with an addition of ROM, RAM, I/O devices and timers. So the additional devices make this microcontroller be called as a computer in a chip. So what are the main features of the microcontrollers? They have multifunction pins. They have bit handling instructions which are more as compared to microprocessors. So have limited data movement instructions, have separate memory map for data and code. So there are limited instructions and addressing modes. Less access time is involved because of built-in memory and I/O devices. So when we talk about the architecture of microcontrollers, there are two main types of microcontrollers. The one what we call as RISC, a reduced instruction set computer, is a microcontroller. So having the reduced instruction set. And the second type, what we call as CISC, is the complex instruction set computer. So what we are discussing here about 8051 is a second type, that is CISC sort of microcontroller. For knowing about the features of 8051 microcontroller, it has an 8-bit CPU like 8085, on-chip clock oscillator. Now the 4 kilobyte internal program memory, ROM. This is specialty about microcontrollers, that it has within the chip ROM is the programmable memory. 8051 it's 4 kilobytes, but we see that there are so many microcontrollers under different identifications, IC identifications, but having the same architecture. Some have the internal memory of 8 kilobytes or more. This is the strength with the microcontrollers having inside a programmable ROM. So this is why we burn the programs and use the microcontrollers for special controlling jobs. So moving to the data memory, it has a RAM of 128 bytes. So but having the capacity of connecting 64 kilobyte external program memory as well as 64 kilobytes external data memory. Then it has 32-bit bidirectional I/O lines or I/O pins used as four ports, four 8-bit ports. The ports can be individually addressed or bits can be individually addressed as 32 I/O lines. There are two counters T0 and T1, 16-bit counters or timers, and then we have for the serial data transmission and receiving system, we have the duplex serial communication available. So seeing the additional features, we have 4 register banks of 8 register sheet, that makes it to 32 registers. So we have the 16-bit program counter and a data pointer DPTR. We have a program status word of 8 bits and a stack pointer of 8 bits, 5 vectored interrupt structure. A reset is not considered as interrupt, so without a reset it has 5 vectored interrupt structures, interrupt, we can say interrupt possibilities, interrupt configurations. 8051 CPU consists of 8-bit ALU with associated registers, accumulator and B register. Then we have the additional registers, that's status word, program status word, that's SP, the stack pointer, 16-bit program counter and stack pointer. So we have this ALU that can perform arithmetic and logic operations on 8-bit of data. The internal RAM of the processor microcontroller is divided into 3 categories. A, the working registers from 00 to 1F. Then bit addressable memory from 20 or 20 to 2F is a hexadecimal, so 20 to 2F. So general purpose memory, scratch pad memory, what we call as 30 to 7F. The architecture of 8051 is that we have an accumulator. To the accumulator we have the B register connected and an ALU connected with program status word. There is a one structure and this structure is connected to the ports, 4 ports, and of course we have the general purpose RAM also. Is with the help of this we can program. You see that we have the program counter, the ROM, and DPTR, and port 0 and port 2 are connected to it for the programming purpose. And then we have this in the 4 ports, port 0 and port 2, they are having the pin structure which is considered to be not only the input output ports but also the address lines, and port 0 as data lines as well. So port 0, A0 to A7 or D0 to D7, or the 8 pins of ports, then individual 8 lines as well, or bit set reset type of individual bits also. We see that the port 1 and port 3, port 1 is simple IO port, port 3 is not only IO port but also has the additional interrupt control or serial data read write operations in additional features. The port 2 having input output operations, bit set reset operations, as well as the higher order bit address line operations. So this is a simple structure of 8051 to understand the chip microcontroller chip 8085 in a simple manner. If we move to the pin diagram, see that is a 40 pin chip having ground at pin 20 and the power supply VCC at 40, pin number 40. Then we see that we have pins from 1 to 8 as one port, the 9 is left, 10 to 17 is another port. Port 1 from 1 to 8, and then port 3 from 10 to 17, 18 and 19 for crystal connections. You see that 9 is reserved for reset. You see that from 21 to 28 another port, port 2, and then PSN ALE program and EA VPP pins. These are all pins used for the external program memory connectivity, and then you see that particularly the port 3 has multiple pins having more than one function. We have TXD, RXD for serial transmission and reception of data. We have interrupt signals INT0, INT1. We have timer connections T0, T1, and we have the write and read WR and RD. Then we have from pin 32 to 39 as port 0. With this we come to the end of this lecture. Thank you very much.